Alright, so those of us playing along at home, sorry that you're not here. Seems like a lot of our 3A class is missing. So you guys are not waiting for me. Those of you that are awkwardly staring at me with like the first screen of Desmos up, stop awkwardly staring at me. Go ahead and start. You're not waiting for me. You're never waiting for me. If I need you to wait, I will have the activity paused. As a side reminder, Schoology, right, has our stuff in it, including like convenient links and stuff like that. I don't know why it's not opening Schoology again, because it's open over here. But this handout from today is in this folder, as well as all the stuff from last week, right? So a reminder, all this stuff was in there if you're trying to catch up on any of that con work, especially this fraction conversion table. Is pretty convenient. But also, as we start getting into percents, it has a percent column over here, right? It's a reminder that that fraction conversion table that we looked at last week also has those percents available. All right, so it's always interesting when we have the, like, which one doesn't belong, because I'm going to anonymize you guys, especially because we're recording. But here's how the votes came out for which one doesn't belong. Pretty darn split. And yeah, there's not a lot of us here. And what's even funnier is this, well, okay, not like haha funny. I would have voted D. None of you guys did. So like your names are anonymized on there. So right now I don't even know who's who. But Griffin, what'd you pick and why?
I picked B.
B, like boy?
Yeah.
Okay. Why? Okay. The only one that showed half compared to the other. Van, what'd you pick and why?
So I picked C. I guess I'll just read off what I wrote. The rest of the model shown all depict blue graphs with either less than or equal to the whole amount of red shapes. Model C, however, has more than the red shape and is the only one with more.
So C shows blue as more. Very interesting. Kyra? What'd you pick and why? You don't even have to have it typed up there. Just which one would you say doesn't belong? There's no wrong answer. Yeah, agree. That's a pretty good, like, hey, that one is weird. That's why I would have picked D, because it's the only one where they're equal to each other. I should just give you guys another couple minutes to keep working. So let's go ahead and keep going, then I'll pull us back together to actually talk about the handout. Go ahead and keep going. Des Best is great. Des Worst is a bunch of scammers. Just go ahead. You'll know once you keep working. If it turns into a toy, we're going to tell you to leave it at home. I don't care whose it is. In that case, I might as well just take it and make it mine. Des Best is increasing their granola bar. Woo-hoo! Give me more. I'm always hungry. Give me more. It is okay if you don't get this right. I just want what your gut response, what your thinking is. And you can come back and change your answer if you find out more. But you don't have to. So go ahead and just give an answer. What do you think? Then keep moving on. It gives us a little model to look at that might help us. Des Worst. Some of us haven't even made it to Des Worst, and you're still like, what? Why? What is he saying?
I'm very scared. Very bad.
All right, so DeAndre, with that 20% increase to our Des Best, anyone want to volunteer? Well, actually, so we're anonymized, so I can show you guys what people said. So DeAndre may have been thinking to break up the 100% into equal 20%, so he could add another easily. I love this. Looks awkward, but I love it. 20%. He thought 15 divided by 5. Now wait, why divided by 5? I don't know if anyone wants to volunteer that that was you. I agree that that's what he can think about. Like, he had this. Why divided by 5? Anyone willing to tell us why you wrote that? It's right.
I know what it is, though.
Okay, but that's not what we're gonna do. Anyone want to say why it's divided by 5? Monsef?
That was me, and I did that because it's 5 equal parts, because 15 divided by 5 equals 3, and if we count by 3s, we get 15 when we count 5 times by 3s.
So, exactly what Monsef just said, but if we don't know that, and we were looking at this chart, 20% is what fraction? 1/5. 20% is a fifth. So maybe that's why they divided by 5, right? Because 20% is a fifth. He divided by 5, or 20%, added the 1/5. He could have found 20% of the granola bar, added it. DeAndre might have thought to do this because splitting up by 5. How much is 20% of 15? Sorry, not enough time to read all of them. Let's keep on going. We're going to switch activities here in a minute. All right, even if you're still overlooking at Des Best, I want you to jump to slide 4. If you're past slide 4, you can stay where you are. But if you're on slide 3, please go ahead and go to slide 4 to learn about Des Worst. They are the worst.
They're scammers.
They're trying to scam us over.
I think Shaq has a commercial about what's happening here.
Can we see it? Wait, what's happening?
No, because we always run out of time in this class. But Shaq has a pizza commercial where he talks about shrinkflation. Shrinkflation. Anyone know what shrinkflation is and able to explain it to us, Callum?
Shrinkflation is, let's say you take your average granola bar. The company might keep it the same price, but they might change the product to be inside to be smaller.
So we take our average granola bar And instead of upping the price, we just say we're going to chop off this much of it, repackage, here's your granola bar. Same cost. Our cost hasn't gone up. But are you paying more? Yeah, because you're getting less, paying the same thing. So inflation is when prices go up, right? Inflation is when prices go up. Shrinkflation is kind of the opposite, where the amount you get goes down, which has been happening with peanut butter, especially at Walmart, for like a while. Because peanut butter is one of those things where a lot of people buy it, a lot of people pay attention to the price. So here's an NEFA strategy. Okay, so we're losing 10%. Can anyone volunteer to talk through how a NEFA got to 0.9? I don't know what 0.9 came from. Monsa, was that hand up or no?
It was, but then as soon as it's over 0.9, I got confused.
Okay, well then hold on. Then maybe Jay can pick up halfway through. Give us the first half then. What were you going to say? Yeah, if you were going to explain what Anifa wrote down here. They wrote down what's in red.
I was gonna say that Anifa knew that 20% is about 3 centimeters, so she just had to divide it by 2. I think it 1.5.
That's brilliant. That's a good idea. Jay, what's with what they wrote here with the 0.9? Because Monsa gave us another way that we could get to 13.5, but Anifa has this 0.9. I don't know what's going on there.
She kind of did, like, he did like this one. The way that she did that was that since she saw that it was a subtraction problem now instead of an addition problem, and so it was minus 10 from 100%.
Mm-hmm.
And so she subtracted 10 from 100% to get 90, which with 10 and like single digit numbers would be 9.
See, if you catch me doing this, it's because I'm used to having a pocket here. I like the sweatshirt aside from that I want a pocket on your handout, which means I should see people picking up these old school writing utensils. What does percent mean? And we're not just going to write down per 100, because that's silly. Per 100 is right here. What does percent mean? Not just per 100. What does that per mean? Monsa?
The per is like every amount of something.
For every 100. You should write this down. So if I tell you, like 67%. Okay, so if I say 67% of the school ate walking taco last Tuesday. It's only on my mind because people were talking about it. I wonder if there's walking taco for lunch. And then it got stuck in my brain that I kind of want to make a walking taco at home. But I don't have Doritos. Okay. So, yes, I need to go to the grocery store. Does this mean only 67 kids got walking tacos if I tell you 67% of the school?
No.
What?
Because there isn't 100 kids at school.
Okay, so there aren't only 100 kids at the school. So what does this mean, though? If I say 67% of the building ate walking tacos last week, Isaac, is that up or no?
Kind of.
Kind of.
I'm just gonna do something. 67% of the full amount of students, maybe.
So if I break the students into groups, it would be 67 out of... So if I break the building into 67, or into groups of 100. Now here's the crazy thing though. In our building, there's approximately 1,000 people. If you count Perry, Phoenix, and the high school. Now the high school doesn't normally eat lunch here, but I'm just going to group them in for today. They're small. They're smaller than us. So if we say there's 1,000 students eating, about how many of them got walking taco?
670.
How'd you figure that out?
Because if 67% of 100 got walking tacos, then 670 out of 1,000.
They gotta be proportional.
Right.
Which is why we just learned about proportions. So once we have our percent values, we can do a lot of different math with them. That's really not good for your chords. You could just put those away since they seem distracting right now. All right, also here, this did not print out correctly on your paper. Get a highlighter, probably not yellow. Get some kind of color.
Green.
For 0%, we do not need to shade in anything. Hey, for 0%, it just said we don't need to shade in anything. For 25%, we should shade in like a fourth of the pizza. Right, if you imagine this is a pizza, you're getting your topping on however much of the pizza we're talking about. So 50%, how much of the pizza should we shade in? Half of it, right? Yeah, 50%. But if we say that in a different way, it's half of the pizza. And then if you pull a little Kevin McAllister, what movie am I referencing? Home Alone, and you get your own pizza, how much do I shade in for 100%?
The whole thing.
The whole thing. He's got a cheese pizza all to himself.
Oh man, I love cheese pizzas. That's the only pizza I eat.
Do you really think that my mother would let me go to the store all by myself? I love how he avoids lying by just asking questions back to the people instead of answering. Watch it again under the pretense of Kevin tries not to lie. And like, when you watch it under that pretense, it's really funny because he doesn't lie. He just asks questions back to people and they're like, well, no, I guess not. And then he does tell some lies, but he does a pretty good job at like asking questions back. So then, guys, read what this says, especially over at the shortcut on your paper. This is on your paper. I just cut it up a little bit differently. This is on your paper. I just cut it up a little bit differently. When we divide by 100, what that ends up looking like is the decimal moved 2 places left. Look up here now. Here's what we mean, and this is where it confuses people. There is a decimal here. At 28%, 28 has a decimal after it, right? Every number can have a decimal written with it. A lot of numbers don't need the decimal. Like, when we say, how old are you? And you're like, I'm 12. You're really 12 point something if we want to be accurate, right? Or 11 point something. But 28. 28.0. So we probably don't put the decimal. But when you divide by 100, like percent tells you to do, because it's per for every cent, meaning 100, what ends up happening is when we read, how do we read this the right way? How do we read that the right way? Who remembers from last week? Mason? 28 hundredths. 28 hundredths. 28 hundredths. 28 hundredths. They're said the same way. So that decimal moves left. It doesn't act like, it looks like it moves. But from percent form to decimal form, if you want to take the shortcut, the decimal moves left twice. So right here, 15.7. Draw a couple arrows if you want to practice this with me. What's that turn into? Here we would say the 0 because it's kind of important. 0 and, or you could say 0 point. Just shout it out. Yeah, 157. Or 157 thousandths, if you really want to say it the right way. Whoa. Hey, to go the other way around, we multiply by 100. So it essentially goes the other way. If you take a decimal number and turn it into a percent, and all of this is on your paper. So if you take a decimal, turn it into a percent, it moves it to the right. Really, we're just multiplying by 100. I mean, the decimal moves, but it's not like some secret thing is happening. All right, I need you to back out of this activity. I know you can see your recent activities, but it's not going to be recent because you haven't started it yet. Go to the other new activity up there. I forget what I called it.
All the equations.
There you go. Wow, that's like we practiced that. All the equations. All the equations. I need us to reach a certain point before I pull us back together, so go ahead and dive in.
All day equations.
Hold on, let's see how this works. No, the clue.
Would Matt Faley please report to the Perry main office for dismissal? Matt Faley to the Perry main office for dismissal, please.
We all getting over into the other activity, all the equations?
I did it.
Remember, some things in Desmos you can do multiple times. Other things, they only give you one chance to try it, and then you just move on. So if it gives you multiple tries, you might as well try to adjust and get it right. But then move on. But then move on. Try to figure out the actual... You guys can also chat with each other while you're doing this, especially if you need to share a calculator. You can work with each other. We're going to increase each of these 21%. Just drag that point and try to make it 21% big. So make sure to make this rectangle 21% longer. So I think you were just trying to go to 21% of it. Yeah, we need to increase it by 21%.
Yeah, let's see this
You're going to want to flip your worksheet over to the back, just by the way. When we come back together. Just say, like, there's a place to put your work. Sorry, I only make things that are two-sided copies, but then I know when we highlight stuff, I should have warned you guys not to go too heavy on the highlighter. Sorry.
That's fine. You make mistakes.
Yeah, it's a lot of my life. But as long as you learn from them, it's really okay. Man, it'd be really convenient if I started at 100, because then 21% would just be 21. But if I start at 120, this 21%, I gotta figure out what that is.
I gotta use my brain.
Or use somebody else's brain.
Can I use your brain? Can I use your brain? Oh yeah, shit. But these are mine.
What does 21% mean?
Oh, you have to go backwards. I see. You have to go from pardon me.
So wait, we started. Right. So we started. So walk me through this. Man, guys, y'all gotta bring handheld calculators. They're way more convenient than using computer calculators. Because then you got multiple tabs. You said you did 120 divided by 100. 120 divided by 100. Okay. And you said you're gonna take that number and you walk away.
And the math is not
Okay,
bad.
do that. You get a different answer.
It's all red.
Yeah, you said you're 30.
I had mine
Oh,
all right.
so I think you did something different the second time around than you did the first time.
I see.
Forget about the second
I
part.
don't
Right?
see
First
a
is
single
that.
pixel of what.
I think you're on to
But
something.
it's actually when you go to quizzes and you use the app, and that's how you get
Yes.
instead of just
I mean, yeah, I can. Sure. Yeah. Are you being precise or not? Because your answers are close. What math did you do? Oh, you took your glasses off. That's why. You gotta have your glasses on to get right answers. Division. No, for real. What'd you do though? Divided what? Like, tell me what
I
division
went
you
to.
did.
Okay.
Okay.
I did. I took that. And I didn't actually divide. I just kind of took it to 6. Low just this.
I don't know what you mean. What do you mean you took 120 to its lowest? I
Okay.
seriously don't understand.
So it's 100%.
Yes.
It's 120. I took what is 20% of 120.
Okay, how'd you figure that out?
I used
That does not count.
What math?
It does not count.
So
I think Scratch really counts. It keeps you made code.
So if it's 25, we're over.
Okay, I hear some ifs now that are getting us away from accuracy. And I think that's what happened here. Is we let ourselves stray a little bit away from accuracy. Alright, bring it back together. That's why we're going to bring it back together. Alright, so we want to increase by 21%. Jay, would you like to tell me what you guys did?
So Lincoln did most of it.
Okay, Lincoln did most of it. Do you want to explain or do you want to let Lincoln?
I don't really know how to explain it.
Okay. So I took like the centimeters
Okay.
and divided it by the percent. And then
What percent? What do you mean the percent?
So like let's say like I took like 120 centimeters and divided it by 100%.
Okay, so hold on. So you went 120 centimeters, and I think this is Mason's way too. And that was our 100%. So then you divided it, and you got what?
We got 1.2.
So hey, give me some attention up here, because this way is awesome. It's one of the ways you can get there. All right, continue.
And so I multiplied 1.2 by 21, and then I added what the outcome was to the 120 centimeters.
All right, so hold on. When you did this multiplication times 21, what did you get?
I got
25, I think it was 25.2.
yeah.
So, one way that you can go. Hey, Sophie, why do you have headphones in? So my question that you probably couldn't hear is why do you have headphones in? Do you have music on? So how did you forget when I'm in the middle of teaching? So let's work on that, because I think part of that was a choice to keep them in since we were working on a computer. So, you could write this down if you want. This is one way to go. You don't have to, because there's multiple ways to go. We took it down to 1%. Built it up to 21%. And what he said, how he took it down was he divided by 100. Like, did the division. Divide by 100, he got 1.2. Then he did times 21. And that 25.2, that still needs to get added up here, though. Right? So we still need to add 25.2. Feels like this is like multiple steps. It'll totally work, though. And it can get us 145.2 as our answer. There's another way we could take, though. Griffin?
So the way I did it was I basically took the original length, and then I multiplied that by 0.21.
Alright, so hold on. Griffin is saying he took the original length. So let's move on to this second one now. Original length, and you did what?
I multiplied it by 0.21.
Okay, and why'd you do 0.21?
I did 0.21 because I took the percent of 21% and I turned that back into a decimal.
Hey friends, if you don't have this written down somewhere, it might be really helpful. The 21%, how we got the 0.21. That's how Griffin got the 0.21. It is 21%. He's doing 21% of 50. What'd you get from that?
And then from that I got
Bless you.
from that I got 10.5, and then I added that back on to the original length.
Love it. There is still an easier way. I put the on. If I say, so you call up Hudson's Pizzeria, because there's my retirement plan. I'm going to run a pizzeria and tutoring business, right? We'll tutor in a room in the back. We'll eat pizza while we do math. So, and Mountain Dew. You got to have Mountain Dew.
W.
So, we're not going to get into that argument right now. It's too deep of a conversation.
Pardon the interruption. Zara Merchant to the Perry office for just a
So I say we've got a special
to the
tonight.
Perry office.
Your pizza is 21% bigger than normal. You get 21% more pizza than you normally do. Do you still get your 100% that you normally do?
Yes.
So in total, in reality, you guys quit with your Chromebooks. I know you're still working on the Desmos, but you don't need to finish it. This is not an assignment that needs finished. If I give you 21% increase, what percent are we actually at now?
121.
Our new percent is actually 121%. What's 121% as a decimal? Anyone? Yeah. 1 and 21/100ths, or 1.21. So take your 1.21. You should definitely write this down. Because that's what you had to start with. And the 21% extra. That's your 100 and the bonus. I don't need to add now. I don't need to do any addition like we did before. Because I already added. This is the addition. 100% plus 21%, 121. So what's 1.21 times 150? I need you guys, you have calculators. What's 1.21 times 150? What is it? I cannot hear you.
181.5.
Yeah, that wasn't me just being like you didn't say it right. I just literally couldn't hear you.
You said 1.21.
Times 150. Did you get something different? Yeah, because now if we're on the third one, right, if we're practicing this other one down here. So, the three different methods we looked at. Drop it down to 1%, build it back up. Figure out the 21% add that on, that'd be 60.5, right? I forgot to write it down, but that'd be 60.5. Or the third method, figure out the new percent and use that to calculate. Alright, so I got like 1 minute left maybe, so we will pick these up tomorrow. But hey, so what we just wrote down, this goes on your paper. This has a spot where it says C equals the new. And I'm just going to write down, like down here, new versus old, but they're using C as the new. Hey, grab a seat, both of you guys. What are you doing? When is class over? No, when I say class is done. And I know that's annoying, but that's why we don't have bells. If teachers aren't done teaching, and I already had to clarify this morning, yes, we have a schedule. That schedule is less important than did we communicate what we needed to communicate to you. So all of us teachers have a deal with each other. If I need to finish teaching and you guys need to be late to your next class, it's fine. Please quit packing up when you feel like it or when you look at the clock. It wastes time because then we have to tell you to stop and sit back down, and it's a waste of time. Class is over when we say, okay, see ya, have a great day, whatever. Class is over when teachers are done. That's why we don't have bells. Are there any questions about that? So here in 3A, I should not have to tell people to stop packing up, like again. Cool. What we just wrote down is that we can use one calculation. Gentlemen, flip back to the back of the paper. We weren't done taking notes. Yeah, you made this take longer than it needed to. Get a pencil back out. We weren't done. We used 1.21 times B but really what will always work is your new percent, whether it's more than 100 or less than 100, times the original value. So tomorrow we'll practice this with the problem down below, like that next problem down, but for your homework. Mason, you're not leaving this. For your homework, you're gonna want to have something like this in your back pocket. Clip this in somewhere safe, your math binder or your big binder, then have a great day. Estes always keeps this class long anyways. Just don't need to tell me about releasing on time. Who what? I know, that's what I mean. He's the one up at, like on the other class. So I'm not worried about getting my class out on time because half the time he doesn't let his class out on time. So if we both run late, it's totally fine because we both lined up. Like the question is my next class in the hallway yet? If not, it's because Estes ran late too.